Part two, mass airflow. Uh, Usually this is a hot wire system. It measures the amount of air coming into the engine. Uh, Now, the way it works, I mean, we could talk all about this, and I have this. It's a Wheatstone bridge, has to do with amperage, and it keeps this little wire inside the airflow. It's trying to keep it, you know, 70 degrees above the ambient temperature, so the more air I blow past it, the more amperage it needs to keep it hot. Make sense? All right. Uh, uh, and then generally this is converted to a frequency. Now, if there's like old school optical sensors. Thank God they got rid of these. Now, one of the things I'm going to look at is I'm going to see if I can get it in grams per second. Okay, and grams per second should be about equal to how many liters it is. Okay, I mean it should be fairly close. So if I've got, you know, I'm looking at an 8-liter engine and I've got about 8 grams per second, I know I'm on the money. We okay with this? So that's kind of what I'm looking for. The other thing I'm looking for is, can it react fast? So I'm going to, punch this thing and like floor it, wide open, throttle it for a second, and I should see the grams per second spike really hard. Okay? And I just use it as a scan tool and should be able to pop up over 100 grams a second in just, an instant. And it tells me that it's okay. One of the things that happens is they can get skewed. We can get false air. Oh, yeah, here's the other thing. There's no actual baro on a MAF-equipped engine. At high airflows, a contaminated MAP sensor will act like a baro. Therefore, the PCM and the baro reading will change. Okay? Anyways. One of the things I got to look at is visual inspection of the air cleaner. If MAF is off, it's one of the first things I check. If that looks okay, I'm going to look and see if there's any fuzz on the little wire sensor. And sometimes you can't see them. You can clean these. I've got a very good friend of mine who uses brake clean. He says he doesn't have any problem with it. There are special cleaners that you can buy for cleaning a MAF, which honestly, I'm surprised at how often it's helped with a lean tip-in or a hesitation offline. Clean the MAF up, takes care of the issue. Okay. The other thing is false air, especially if you have like an intake tube, like the MAF sensor is here, and then there's an intake tube that goes up to the engine. These guys tend to, if they're cracked or if they come loose or, somebody didn't put the hose clamps on right, we can get false air coming through here, which also, if we have like a big vacuum leak or something, or some vacuum lines are cracked, that brings in false air. Computer reads this much air, engine's actually getting this much air, and that's a problem. All right. And when in doubt, take it out. MAF sensor is disconnected. PCM substitutes backup values. These are the default values that we talked about earlier. Engine runs okay. MAF is probably bad. When in doubt, take it out. You got it. It has to set a code. Okay? We really need to get it to set a code on whatever you disconnect. GPS, that kind of stuff. Anyways, oxygen sensors. You guys have all looked at oxygen sensors before. I don't want to spend too much time on it, but we'll spend a minute. Oxygen sensors switch rich and lean and rich and lean. Problem is they don't know how rich or how lean they are. We okay? All it knows is it's above or below about 14.7 or about, it's a little less than that. But it doesn't know how far it is. All it knows is it's either rich or lean. And I have a real problem with the terms rich and lean. We need to leave that for another video. How do they work? Well, it's pretty simple. We use outside air, outside the exhaust stream, which has 21% oxygen, and inside the exhaust stream has less. Well, the oxygen sensor element produces a voltage because of this differential. We okay? So here's an oxygen sensor that got coated with a bunch of mud, 4-wheel driving, and it blocked off the intake the fresh air intake of this thing and really threw it off. Honestly, it just needed to be cleaned and it was fine. Some of these oxygen sensors breathe through the wire on the oxygen sensor. So you got to take care not to, kink those oxygen sensor wires, or, if you're going to, if you got to make a connection to these oxygen sensor wires, don't use solder. All right, here we go. O2 sensors tend to switch between about above 900 and below 100. Okay, as they start to age, as it degrades, the range narrows. It goes 800 high, 200 millivolts low, and as long as it does this evenly on the top and on the bottom, it's fine until it gets to like 600 and 300, or 500 or 500 and 200. Anyways, as long as it does it evenly on the top and on the bottom, it's fine. It's where it starts to shift and skew that we start running into problems. They're called either rich biased or lean biased. We can test these things with a bunch of different ways, but the trick is to be able to look at the range of it. Okay, we can test it with a DMM. We can test it with a scope. We can even test it with a scan tool. Okay, so what we want to look at is, can it, go the full range, and is it skewed one way or another? So I just need to make sure, it goes above 900, below 100, above 800, below 200. You get it? If I'm getting, 900s and 200s, that's a problem. That's shifted rich. You get it? All right. And it should switch extremely fast. How often should it switch? 3 to 5 times a second is about normal. Anything more than that is generally considered from a misfire standpoint. You can find this number on a lot of scan tools. It's called cross counts. So if you have it, you can go look at it. If not, you just have to count it, which you may not be able to count that fast. Oh, and if it's less than like 3 times a second, usually that indicates a dead sensor. Cat food. I didn't have a picture of a cat, so I used an ostrich. It's a long story. In order for the cat to stay healthy, it needs to have alternating currents, alternating rich and lean exhaust. If it stays too lean too long or too rich too long, the cat dies. The rich exhaust will kill the cat. Rich all the time will kill the cat because it's overheat. False lean readings, generally a crack. We can get a crack. I mean, even if I have like an O2 sensor here and the exhaust is going past it, even if it's, the O2 sensor, there's a break past the O2 sensor, we can still pull some air, some oxygen up into the exhaust for several inches past the O2 sensor, which can give it a false lean reading. Ignition misfires, I covered that. High oxygen content is generally considered lean. So if I were to disconnect a spark plug, would it be rich or lean? Well, it'd be lean because it's a bunch of oxygen. Remember, O2 sensor monitors rich and lean and rich and lean and rich and lean. It monitors oxygen. It does not monitor hydrocarbons. Are we okay? And then these things can get contaminated. Here's one that's contaminated with antifreeze. It actually has a green tint to it. It can get contaminated by oil. This is a fairly high authority sensor. When the engine's operating closed loop, if the sensor is skewed at all, shifted rich or shifted lean, it can cause us issues. And we're back to it again. When in doubt, take it out. Unplug the thing. It'll set a code. It'll stay in open loop. And if the problem goes away, I know I have a problem with my O2 sensor. Get it? When in doubt, take it out. Okay. Scan tool data sequence. I'm going to get at the car cold. I'm going to make sure, baro is equal to map. I'm going to check on ECT, make sure that's the same as IAT, and all the rest of the temperature sensors are the same. This is cold. This is before I started to bring it into the car or into the shop. And then I'm going to run through the oxygen sensor test. Now, uh, when the ignition is first turned on, most cars put a bias voltage on the oxygen sensor line. And as the oxygen sensor is heating up, its resistance is pulled down, and that bias voltage will be pulled down. Generally, it's about 500 millivolts or something, and then so when you first turn the key on, I'm watching the O2 sensors, and all of them should be diving all at about the same rate. If they're not, usually that indicates a degraded sensor. Anyways, all right, fine. I'll plug this in here. The after the catalytic converter O2 sensor, it is not used for drivability. And when we start talking about cats, I will put this in here. This after the cat O2 sensor. Uh, Realize it can cause drivability problems when the PCM goes into cat testing. We okay? And they can be really weird. Watch the cat presentation. That's where I go over that. All right, position sensors, analog, digital. This is just a straight magnetic. There's a magnet right here. There's a tooth wheel that goes by. This is a voltage generating device. This generates AC. It's got two wires, generates AC. There's a magnet and a coil of wire. We okay? Here's a magnetic sensor on a crankshaft. Here's my crankshaft, and this guy's just kind of sticking in the side, and this notch upsets the voltage coming out of this sensor. Sometimes these guys can get cracked, the magnet can get cracked, and then we end up with a weak magnetic field and a weak output. It shouldn't be cracked or melted. If you see anything like this on these sensors, it's time for a new one. They produce AC voltage. It has two wires. This is what it looks like. As it speeds up, the voltage amplitude gets higher and the voltage humps get closer together. As you slow down, the amplitude voltage drops and it stretches out. We okay? Honestly, you can fool these guys by just holding one of those big soldering guns up against it. Just hold it up against it, the big soldering guns, big Weller guys, just push it up against it, and you'll actually see like vehicle speed pop up on, the sensor, and it tells you all the wiring is good. I don't want to talk about this, and that's about it. We good? Thanks for watching.